Hey guys, today's video is about mean absolute deviation and standard deviation, and I'm just going to pose some questions and kind of a scenario for you to help understand this. So let's say you took a survey of 9 of your friends and how many miles they ran on some random Tuesday. So one of your friends ran 0 miles, one of them ran 1, or really 3 of them ran 1 mile, so on and so forth. So you get the data and you want to analyze the data. You find the mean, which turns out to be 3. You can find the mode, right? It's the number that repeats the most, so it's 1. You can find the median, it's the middle number, so that would be 2 in this case. You can do all that stuff. But as you're looking at all these numbers, you realize that some of the data points are kind of a lot further away from the mean than others. Like 8 is 5 away from the mean, whereas 3 is 0 away from the mean because it is the mean. So you're looking at all these numbers and you're like, maybe I can write the distance between the mean and all these numbers and then kind of see what that data set looks like, right? Why not? So the difference between this 0 miles and 3 would be 3. Difference between 3 and 1, this would be 2, 2, 2. 3 and 2 would be 1. 3 and 3 is the same number. This would also be 1, 4, and 5. So this is the how much each data point differs from the mean of the data set. So now we have a new kind of data set that we got from this one, and it's telling us the distance of how far away each number here is from the mean. So now we have 3, 2, 2, 2, 1, 0, 1, 4, 5. Okay. Now that we have this, I want you guys to try to play around with this new data set. Can you find the average of this data set, the median, the mode? So take a couple seconds and try to do that. And then once you do that, I want you guys to try to figure out, if there's some kind of process or steps or formula that you can get that you can derive that got you your mean, median, mode from this data set, and what those values actually tell you about the original data set. So take a second and do that. Okay, so I rewrote the data set so it's from least to greatest so we can find the median a lot more easily. I also wrote down the mean, and the mode is 2. So median's 2, mode is 2, and the mean is 2.2 with a vinculum over it. So take a second and try to figure out what this really means in terms of the original data set, right? So this is the mean of the distances away from the original data set, right? It's the average distance away from the mean of the original first data set. So I just drew a number line here to maybe make it a little more easy visually. So if this is the mean, and it's the distance away from the average, which is 3, of the first data set, then this is going to be 2.2 here. This is going to be 2.2 here, because again, it's the distance away from the original, and it's the average distance away, which we got, right? So this is going to be 5.2, this is going to be 0.8, and yeah, so what this, in math, there's a word for this kind of process or formula, is called the mean absolute deviation, or MAD for short, and that's what this is. This is the MAD of the original data set. So let's just do a quick recap and summary of what we did. We had the first data set. We got the mean of the first data set. We then realized that some of the data was a lot different from or a lot further away than other data. So then, we got the distances away of each data set from the mean, right? This was 3 minus 0, 3 minus 1, whatever. And we made sure they were all positive. So a formula for this could be like each number of the data point 0, or 1, or whatever, minus 3, and then the absolute value of that to make it positive, to make sure it's just the distance, right? We got all of those. And then we just took the average of that. And that was basically it. And that tells us how much kind of the average deviation is from this data set. And yeah, you could also do that with the median. You could figure out that 2 is like the median of away from the average. You can make this also the median, figure out the median away from that. There's a ton of stuff that you could do that tells you different stuff about this data. And we're going to move on to standard deviation next. Okay, so there's another kind of calculating deviation from the mean. It's called standard deviation. And it's almost the same as mean absolute deviation, but instead when you subtract the number from the mean, or the mean from the number, so like let's do 0 minus 3, right? And instead of just doing that for all of them and adding them up and dividing by how many numbers there are, you would do this, square it, and then add up the other ones too. So 1 minus 3, square it, stuff like that. And then, once you divide by how many digits there are, I'll call it n, after you do all that, you're going to want to square root it. Okay, so I'm going to explain kind of why this is. And again, this is going to go on until you're done with the data sets, not just those two. But this is because when there's like an extreme outlier maybe in a data set, if you do this method instead, then that outlier, like if this was like 26 minus 3, right? That would be 23 squared. So that would be a huge bump to this numerator. And then when you divide it by the denominator and then square root it, that standard deviation is going to be absolutely huge in comparison to if there wasn't an outlier there, or maybe to the mean absolute deviation. So really what this is doing is kind of amplifying those outliers. And I mean, yeah, that's basically it. And you might be wondering, well, why can't we just square it and then divide by the digits there? Think of this in terms of units, right? This is 0 miles minus 3 miles squared. So right up here, this is really miles squared, if we're just doing it in terms of units, divided by how many there are, which doesn't have a unit. So if we just have miles squared and then yeah, so basically if our answer is in miles squared, that's a different unit than what this is in, which is just in miles regular, miles to the first power. So we square root it to try to get it to the first kind of unit so that we can actually compare them. And yeah, that's basically it. If you want, you can try putting 26 in this data set, finding the standard deviation, the mean absolute, and then comparing them. Oh, and once you do this the standard deviation, you would get 2.67, and our mean absolute deviation was 2.2 with vinculum over it. So yeah, as you can see, the numbers are amplified more, so this standard deviation is always going to be greater than or equal to the mean average deviation.